Hello, people, and welcome again to one of our talks here in Devweek. I want to welcome you and thank you for joining us another day. And for today's session, we're going to have a great person, Rob Armstrong, over here, who's going to talk about AI and more artificial intelligence, how to enable and use AI effectively. Let me tell you a little bit more about Rob. Rob, since 1987, has contributing in virtually every aspect of of data warehouse and analytical areas. So his work has been dedicated to helping companies become data driven and turn businesses insights into action. So he has a lot of expertise, a lot of experience in all of those areas. And before we start, I just want to remind you to follow us in our social medias that will be appearing a little bit there. And, well, to join us in future events and presentations today. Also, if you want to leave a question, there's a chat box so you can send us those questions. And, well, Rob, welcome and take it away.
Great. Thank you very much for having me, and I appreciate the opportunity. Um, this is a topic I've been having quite a bit of fun with lately, so we'll just continue that fun here today. Um, just a little bit more about myself there. A great introduction. You can see I kind of say I'm a data and analytic enthusiast, and it is all about how do companies take the data that they collect and turn that using analytics into something valuable. Because having data doesn't matter if you don't analyze it, and analyzing data doesn't matter unless you do something with it. And that kind of gets us into what people are trying to do these days with the rise of AI. I did this session just last week, and in a room of about 150, 200 people, I said, how many of you are actually using AI right now in your business? And I was not surprised. No hands went up, but everyone's interested in using AI in their business, and how do they do that? So as I thought about that, and I've been thinking about it for a while, is the joke that one of my colleagues and I have is that artificial means not real, and intelligence means smart. So AI must mean not real smart. And that's where I come up with this title that is it really more artificial than intelligence? Because AI by itself can go awry very, very easily. And so we're going to show some examples of that. We're going to talk about what are the big problems, what are the big pitfalls when using AI, and then get into, so how can I enable my environment so I can then use AI effectively? So I'm going to start it off with just a quick story, as I like to do. Is I don't know how many of you have ever been on a safari. I spent 3 weeks in Africa for my honeymoon. We went out to Southern Africa. We went out and we saw the animals. We saw the big five, saw 6 of the big 7. Need to get back there to see the cheetahs. But it was a very, very cool event. And you're out there, you're going out in trucks, or you're walking around along the savannah, and just really experiencing life as it should be. But there's interesting things when we come into AI. Somebody sent me this picture because I knew I'd been in Africa. So he sent me this picture, and the more you look at this picture, the worse it gets. Right? So you look at that and you're like, okay, we're out on safari. I like that. And there's a truck in that picture. It says with close to 63% probability. It's got some people in there, again, about a 64, 65% and a 50% possibility that those are people. And then we have what appears to be a cow with 96% of certainty. Now, I know that's not a cow. You know that's not a cow. My 4-year-old nephew knows that's not a cow. How is it that AI, and I'm using that term broadly with predictive analytics and data science and other machine learning type tools and all that, how is it gets that so wrong? Because that is not a cow. And the funny thing is, so we were in a truck like that, and my wife asked, hey, why don't the lions, because that's a lion in case you haven't figured that out yet, Why don't the lions attack us? And he said, well, we're in a truck. It's smelly. It's big. He really can't see what you are. But if you were to step out of the truck, he will kill you. Like, oh, great. Let's stay in the truck. And it is amazing, all the stories that you hear of people on safaris in the little drive-through parks that want to get out of the car and pet the lions because they just look so darn cute. And they do. But don't try that. Don't go out and try to pet this cow, or worst case, milk this cow, because that will go bad very, very quickly. So I asked, how does this happen? How is it that AI and our algorithms got this so wrong when we could take almost any kindergartner off the street and they can get that right? Well, that's a good question. It may be that the context of the picture is throwing the algorithms off, because you don't expect to see a lion in tall grass with a truck. So typically when you see an animal that's in tall grass with a truck, they were being shown pictures of cows. And so they go, oh, well, based on the context, that's kind of a cow. Because normally when you see lion pictures, they're by themselves lying down in the ground in a basically a open space, and they have lots of little lions around them and all that. So that could be the reason. But whatever it is, this kind of highlights that artificial intelligence is not the smartest among us, which has always been the promise. Artificial intelligence would be the smartest among us. And that's what we look at. What is AI? It's all about mimicking the human performance, mimicking our functions, being human-like in intelligence. So given that last example, maybe they're trying to mimic the intelligence some humans I know, because I know some pretty stupid human beings. And those aren't the intelligence that we want to mimic. We want to mimic the best among us, not the worst among us. And we all know people who are not so smart. So let's try and figure out, how do we get artificial intelligence to emulate the smart people's intelligence, not the not so smart people's intelligence. And that's what we all want to do. Now, before I go much further, I just want to say AI has a lot of very, very, very good applications. It can do things extremely well. It is very good at understanding probability and understanding patterns. Right? It's great at that. And that's kind of how it works. It's really good at those sub-second type decisions that have to happen very, very quickly. I have a lot of information coming in. Self-driving cars is a perfect example. I'm constantly having to make self-driven decisions in sub-seconds. AI is really good at those type of things. It's not so good on some of the other things. And we'll see that. So let's just take a look at this. Artificial intelligence has been around for a long, long time. Certainly the concept of it has been around a long, long time. And in fact, if you go to almost any sci-fi movie back in the 50s, they always talked about, the computers getting smarter, they're owning us, they're controlling us, right? Terminator, Skynet. And that's kind of what's happening, is that the expectations of what AI can do have been very, very elevated. And as we're starting to use AI, we're starting to see, there's some places where it's not that good. Two things I'll cite here is OpenAI wrote an article where they basically said that ChatGPT admitted that ChatGPT could come up with plausible sounding answers that are completely untrue, but they sound plausible. And here in Texas, where I'm living, we had a judge throw out an entire case because the attorneys asked ChatGPT to come up with some trials to quote, and ChatGPT came up with trials. It basically created trial scenarios that did not exist, and they were citing case law that did not happen. And the judge says, you guys are out of here. Your firm is out of here. And until you can prove to me you're not using these techniques. So we're starting to get into that trough of disillusionment that people are starting to use AI and coming up with some of the known issues. So let's take a look at some of those. What are these problems? Here's what I liked about AI. And again, using that broadly, decision, data science, predictive analytics, machine learning, all of that. AI will never shrug its shoulders and say, I don't know. I give up. You got me on that one. It will come up with an answer, right? ChatGPT says it will come up with a plausible sounding answer that is incorrect. So you'll get an answer, right? We'll show you that that's a cow. It's not, but we'll say it's a cow. You'll get an answer. And unless you know it's not the right answer, you'll take it as right. And that's a problem. AI says things with such authority that you almost have to believe it. And that's kind of ironic, is that we have to use our own intelligence to understand when the artificial intelligence is telling us something that's not true. Now, that's very hard to do if you're not a master in the subject area that it's presenting to you. Or if you don't know a lion from a cow, that would also confuse you. So that's the first problem. You're going to get some answer. The second problem is that you will get very precise answers. Answers with enough significant digits that it looks like, how can it be wrong? I remember during the pandemic days where every single day we got models that predicted how many people would catch COVID or die that day. And they were so precise. It was, we're going to see 835,412 people get COVID today. And you're like, wow, that's pretty precise. It must be accurate. Again, precision doesn't equal accuracy. But when you get a number like, oh, it's going to be 200,000 people will get COVID, you look at that and you go, that number just sounds made up. About 200,000? Well, that sounds made up. If you had said 197,406, you go, wow, that sounds precise. I got to believe that number. So AI not only comes up with some answer, it comes up with an answer that sounds really, really true. It's all just math. And by the way, AI doesn't do math well. That's the other ironic part of it. The last problem I have with a lot of these routines is that they are so complex that people don't understand the math behind it. And two, they are very, very often not repeatable. If you put the same data set through the same algorithm, you may get different numbers. A lot of that comes in when we do different training sets. We take a 20% sample for our training set. Well, every time I run that, I'm going to get a different 20%. So that means that my training set is different, which means that when I go against the full file, that answer is different. If I cannot run a complex algorithm that is repeatable, how do I know which answer is correct? So again, we get some answer from a highly complex process that looks really precise, and we go, it must be right. What is causing all these problems? Why is it that these problems come to bear? Well, it's no surprise that it's the data. Right? Data is the foundation for everything done in artificial intelligence. Andrew Ning, and I hope I'm pronouncing it correctly. Sorry if I'm not, Andrew. But he had basically, this is a quote from a few years ago where he said, data is a unified data warehouse is the foundation for an artificial intelligence. And his point being, it's still true today, you just change some of the names around, is that data is at the heart of everything. And then from data, we have a bunch of other things that happen. We have sourcing, we have conditioning, we have reconciliation, we have curation, we have validation, we have different people doing different things with it. And then we finally get to data that we give to some code. And gee, that code does something, again, that we may not really understand. It comes out with an answer. If the data process is wrong, your AI process is going to be wrong. So the next couple things we're going to talk about is how do we make sure that our data is good so that we can have a little bit higher trust in the answers we get from that data. Let's pop into that and have some fun with this. In the military, there is a great saying that as alone I go fast, together we go far. And what that means is that if I'm all by myself, I can run, I can do all of these good things because I don't have to worry about other people. But we go far together because we help each other. And data and analytics is a team sport. We can't be constantly isolating. And the problem is in a lot of AI exploration and a lot of AI innovation, we give data to a group of people that go off on their own and then come back and say, well, here's what we came up with. And what we need to do is not constantly break out data into little silos. We need to get more cooperation, right? Because, yeah, you might be going fast, but are you going fast in the wrong direction? And we've seen this with data for years. We've seen the same thing with reporting, decision support, predictive analytics. We see that data is created, it's curated, and then it's made available to the business. But in order to get around the IT bottleneck, right? IT's the problem. I can't get my data fast enough. People start either doing extracts from that curated, highly governed environment and then going off on their own, or they just get data off themselves before it even gets in through that curated, governed stage. And so we start building all these data silos, and this creates data drift. It creates data redundancy, which, by the way, is what you pray for, is redundant data, because 99.9% of the time it is not redundant when it should be. And so we start getting data that should be the same that isn't, and we have people doing different explorations against that data and coming up with different results. Just a simple example. How many times have you been in a meeting arguing about who has the right numbers on a report? And that's not even AI yet. That's just simple reporting. And we can't even agree on what the data is. It's because people are not using consistency in the data. So if you want your AI environment to help your business, it better be using the data that is consistent with what everyone else is using for the business. I can't use different data sets for AI and advanced analytic capabilities that's not the same as the data I'm using to kind of just run the business, the reporting and the dashboards and all that. It needs to be consistent. So I read a great book. It's called Robopocalypse. If you've read it, congratulations, because you're the only other, I've only met one other person in the world that's read it. He was down in Australia. And he was a very interesting person. So I knew that he would probably have read it. But in the book, and if you sense you haven't read the book, you've seen the movie. It's called Terminator, right? Skynet becomes self-aware. They figure out the problem with the world is people. Let's kill all the people, right? And that's the fear of AI. It's going to figure out the secret that we're really the problem. But in the book, there's just a great quote here, right? Is that basically data by itself, it's interesting, but it has no context. I don't know if it's good, bad. Is it right, wrong? Is it useful, useless? I don't know. Is it timely or not? I don't know. Data by itself is interesting, but most part useless. It is the relationships between the data that make it fascinating. It is not until we apply relationships to data that we understand data. And again, AI is all about understanding patterns, probabilities, relationships. And AI is really good for finding relationships that we don't even know exist, because there's so much data that we can't understand all the relationships. And that's why we have these very complicated algorithms to go through the data and lots of different statistical algorithms and other processes to understand, is there any correlation? Is there any relationship? And if so, what does it mean? So that's what we want to do with our data. We want to make sure that we preserve the relationships to the data. Now, luckily, there's a way we do that. It's called relationship modeling, right? Entity relationship attribute modeling. Normalized modeling, that's another term for it. But it used to be very easy because all the data that we had in our business came from our business. We created it for the business. And it was created in a way that people understood in a relational architecture. So you understood the relationship between the data, and that was all good. The problem came when we had all this other data, which created more relationships, which made it more fascinating and more useful, but it created bigger problems. So now we have all this data, a lot of which we don't create, a lot of which we don't control internally, but we need to use internally so we can influence external events. So again, you're getting this very tight, well-known, governed group of data, and now it's starting to explode into this environment or universe of data that's all over the place. And what we want to do, what we must do, is make sure that we could literally connect the dots of all this data. If you can't connect those dots, if you don't understand the relationship between these dots, then AI will find them. It will find one. You won't know if it's true or not, but it will find something. So a couple things here. One, we want to make sure that as we get this data that, for example, my sensor data is well known, but that the ID of that sensor is known to the manufacturer so that I can link into my manufacturing process. And that manufacturing, that piece for that sensor is known where it went into what car, what a piece of equipment. And now I've got a bigger relationship. Who did I sell that piece of equipment to? Now I know my customer. And that's what we need to be able to do to be able to drive on this. So big point here. A little bit of a tangent, but it's a big point. We've got this universe of data. And what we want to do is make sure that the data at the edge, which is raw, uncurated data, is at the edge. As you go toward the middle, you have more governance, more curation, more value, more users, all these fun things. This came from a blog called Circle and Square. So go out to teradata.com and go to the blogs and you'll find it. But the question I have for you is, how do you know when the data is in the right place in that continuum from the outer raw edge to the inner well-governed, well-curated edge? How do you know when you have data in the right place? And typically I would throw out some fun gadgets, but I'm not there in front of you live. So I'll just let you know that the data is in the right place when the value of having it there is worth more than the cost of getting it there. So for example, raw data at the edge, I have 2 or 3 people doing some fun exploration, innovation with it. Great, that's fine. But I would not use raw data to report to the street my results because people go to jail when those are raw. So as I curate, right, as I get more value to the data, I'm willing to curate it more and integrate it more. So again, this is the way that we're going to prepare our data so that it is useful and ready for AI to take advantage of it. Because you've all heard this saying. If you haven't, then welcome to IT. Welcome to the world of data. Garbage in, garbage out. And that's what we've been having. We've had bad data get in. AI is playing against that bad data, and we're getting an answer out of it that we can't possibly trace the lineage of all of it. And so we have to say, well, it's right unless I know it's wrong. And again, that's the kind of the irony of AI is we accept it's right until we know it's wrong, right? I almost would like to go the other way. Question AI results until you can prove that they are correct. And that's the good way to do that. So let's take a look at some of the lessons that we've gotten from this. This is just an example of using sensors. Again, when I did this conference a couple weeks ago, I asked who's using IoT, right? Internet of Things, sensors, who's using that in their analytics? And I had very few hands go up. Maybe in your crowd, there's more hands that would go up. But this is just some things that we've learned, and this is tied to sensors. It's not explicitly only sensors, because there's a lot of other areas where this is true, right? That the data sometimes lies to you. It doesn't want to lie. It does. Sometimes data is gathered incomplete and inconsistent. So when you gather data, you need to make sure that it is going through a curation process and it's becoming more correct. And again, you do that through looking at it, understanding it, testing it. And then when you correct it, you want to get that correction back at the beginning. Right? You don't want to correct it after it was bad and move forward. You want to get the correction back at the front. Even when they don't lie, they don't know everything, because the sensor cannot possibly collect everything because there's so much to collect. So when we build sensors, we determine what should be collected. Okay, that's kind of a problem with AI, is that we're determining what gets collected, which introduces bias, or it introduces a lack of knowledge. Right? If I don't get all the data, all being a big word, how do I know that I've got all the relationships? So we want to make sure that we're collecting the information that's necessary. Of course, data that's necessary is going to constantly be changed. So we need to go back and revisit how we're collecting data. All right, and then a couple others is that we got to do lots of different analytics on it to validate it and to come up with insight from it, and make sure that we have data quality wrapped in all of that, and be able to drive that. But kind of as my universe, my circle, my universe of data showed, is that by itself, 0.5 there, that data by itself is not actionable. I need to be able to attach that data I'm getting from a sensor to a product, to a customer, to a usage. Then I can act on it. But data by itself is frequently not actionable. And that is kind of, again, that paradox is that in order to make it actionable, I need more data. I need more relationships. So the more data I can get in with AI, the better. However, too much data, I start introducing data that doesn't even need to be there, then AI is going to try and make sense of it. Just a fun story here, because I like to tell fun stories. When I was in 6th grade, my math teacher only gave us word problems. Right? We hated him until we learned that that was really good. And he would give us word problems that have data points in it that were completely irrelevant to the problem at hand. And what we were learning is, how do you discern what data is meaningful to get to the output that you want? And so it's a very, very valuable lesson. And one I think that should be learned is that we can't just throw all data at AI, but we have to understand what is the problem we're trying to solve so we can get the correct data into these algorithms. Because if you overwhelm it with data, it will try to make relationships. It will try to include the data in there because you told it to. And if that data does not make sense towards the outcome, then you're going to have a problem. Now, that implies you know what outcome you're trying to drive and what you're going to be doing with the answers that you receive. More on that in just a minute. So, won't go into details about this. This is basic data quality, data cleansing, data governance, right? You need to make sure that you understand what is the data that you have, what's a good profile of that data. The people that create the data and use the data should be able to tell you that. You analyze to understand when it's out of tolerance, and then figure out why does it get out of tolerance, create corrections for that, input it back at the beginning of the stream, and then monitor to see if your stream has gotten better. Have you tightened down the tolerance of good and bad data? So classic data quality 101. Lots of things have been written on this. My point to you is, if you're not implementing data quality processes up front, don't expect the AI and the algorithms to do good work. Now, again, interestingly, you could actually use AI to do some of this, but you only do that once you understand the process. And that gets us to where you need to drive collaboration across your user community so that you can basically know what people are using. And I like this idea, Yelp for data. If you know who's using the data most frequently, they're probably the people who know the most about the data and what it should be. So you want to talk to the ones who create the data because they know how it got created and why it got created that way. And then you want to talk to the people that are using the data to understand, is the data being collected useful for the business process that you're trying to drive? If not, why not? What are the problems that you're seeing with it, and be able to go from there. And then the other part of that exploring that collaboration is to just start playing with the data, start using it, not trusting it yet, but using it, get it into some algorithms. One of the points I like down here is that I want to see if my historical data predicted the present. Because what a lot of people do is they take present data and see if it predicts the future. Well, hey, if I had data 5 years ago or 3 years ago, could I have predicted the current? Because, if my algorithm's right, I should be able to do that. Caution, warning, be careful. Because of the pandemic and everything that got thrown into turmoil, the last few years of data is not very predictive for the future. So we have to understand that some of the data that we have to do predictions is actually not very predictive. All right. So I'm going to do closing thoughts. I see my 30 minutes are up here. My closing thought. I'll just ask if anyone's ever participated in a science fair at school. Right. I went through one when I was in junior high. They have a science fair. You choose a science project and you create all these interesting displays. Now, I do not know why, but somebody always does a volcano and the volcano always wins. We don't know why that is. This happened when I was talking with the group last week. The person raised their hand. They said, yes, my daughter did a volcano and she won first place. This is what's happening with AI right now. We're having a lot of what they call data science fairs. We have everybody working independently in little tiny areas and coming up with something that's interesting, but is it useful? Is it going to drive some new innovation? Is it going to drive some new way of doing business? Is it going to change the way we do business so we can better the revenue and outcome of our actions? Ask yourself, are you having an AI science fair, or are you tied to business initiatives that is going to leverage data with very good AI type technologies, but using them in a way that makes sense, that can then better your business? Because that's what we're all trying to do, just better the business. So with that, I want to say thank you. Let's try to make artificial intelligence the best among us, not the worst among us. And remember, verify before you trust. And on that, I'll turn it on back and entertain any questions that we may have.
Thank you so much, Rob, and thank you for the great presentation that you had over there. Definitely, the one at the beginning was not a cow, and I could see that from the start. Yeah, thank you so much. It was great, the information that you shared with us. And to the people over here, remember that you can make questions here in the chat. And remember also that you have to return to the official website here in the calls, so you can go to next talks. Follow us on our social media. There it is in the screen right now. And well, thank you for your time over here, Rob. Thank you everyone for the time that you spent with us, and see you next time.
Great. Thank you very much. Appreciate the opportunity.